Good morning, guys. Welcome to my basement, and this is how we will be having lesson from now until June. Today, I'm actually this is my first try, so bear with me. I'm going to attempt to teach you remotely Chapter 7.3 called Special Products of Binomials. The goal of today's chapter is for you to learn two separate patterns, one called squaring binomials, and the second one called the difference of square patterns. I will give you 3 examples for each one, and they very much mirror what you will be doing in your assignment. So what I would encourage you to do is actually to take out some paper and take these notes with me. I will be pausing on occasion to give you a chance to try it on your own first, and then you can check your work because I will give you the answer. So go ahead and pause it now. Go ahead and write down the title and the first pattern, squaring binomials pattern, and we'll get to it. All right, so here is a first example of squaring a binomial. So I'm going to have x plus 3 squared. As you might recall, this is a polynomial, but it's a special kind of polynomial called a binomial because it has 1 and 2 terms. Because it has 2 terms, it's a binomial, and we're going to be squaring it. Now, what might be very tempting for some of you to think is that, well, if I have x plus 3 squared, the answer is going to be x squared plus 9, because x squared is x squared and 3 squared is 9. I got bad news for you. That is wrong. It looks right, but it's wrong. So don't ever do this. In a class, I had a poster, and I said every time you do this, a puppy dies. That poster, you can't quite see it now, but trust me, it's there. You can check it out next year. So don't do that. That is not the right answer. What in actuality you should be doing when you do x plus 3 squared is you actually have to square the binomial. Now remember that to square something means to multiply it by itself. So it looks like this. It's x plus 3 times x plus 3. And of course, to do that, we're just going to use the pattern that you've learned already, the distributive property, or as we called it, FOIL. So we'll go the first in this parentheses times the first in this one. And that will give you x squared. Then the O, the outsides, and that will give you 3x. Then the I, the insides, and that will also give you 3x. And then lastly, the 3 times 3, and that will give you 9. So the correct product of x plus 3 times x plus 3 is going to be x squared plus, notice that these are like terms, so I'm going to combine them, x squared plus 6x plus 9. And that would be the correct answer. Let's try 2 more examples of this pattern, but this time I'm going to put a negative here. And what I'm going to ask you to do right now is to write that down, then pause the video, do it yourself, and then play the video and see if you got it right. Go ahead, pause it. Okay, here's what you should have had. You should have rewritten this as x minus 2 times x minus 2. Multiplying x times x, you get x squared. Multiplying x times negative 2, negative 2x. Multiplying negative 2 times x, negative 2x. And multiplying negative 2 times negative 2 should give you positive 4. Notice once again that these 2 terms are like terms. And not only are they like terms, but they're the same. That's why this is a pattern, because there's a pattern here. So you're just going to take these 2 guys, add them together once again. So you're going to get x squared minus 4x plus 4. And if you get that, you're doing it right. And when you go do your assignment today, you're not going to have any trouble. Let's do one last example. A little bit harder, but not really. So let's try 2x plus 5 squared. Once again, pause the video, you try it, then come back to make sure you're doing it right. Here's what you should have. You should have 2x plus 5 times 2x plus 5. So multiplying, same old pattern. 2x times 2x is 4x squared. 2x times 5 is 10x. And now I get this pattern. So I know that the next thing is probably going to be 10x again. But let's just make sure. 5 times 2x, 10x. Yep. And then 5 times 5 is going to be 25. So you're going to have 4x squared plus 20x plus 25. And there you go. That is how you square a binomial. It's actually pretty easy. You take the binomial, you expand it, you multiply using the FOIL pattern. All right, that's half of it. The other half of today's lesson is another pattern called a difference of squares pattern. Now this one is very famous, and you will see this pattern a lot in your high school career. Difference of squares. Let me make sure I do this right. Oh yeah, I'm good at this. All right. Okay, a difference of squares looks like this. Let me give you an example. Let's multiply x minus 3 times x plus 3. These are two binomials that have the same terms in a sense. They both have an x and they both have a 3, but one has a plus and one has a minus. When you multiply these, the answer or the product ends up being a pattern called a difference of squares. It's a very famous pattern. It's easy. You could probably do it already, but I'll show you how. We're going to multiply x times x, and we're going to get the x squared. We're going to multiply x times 3, and that will give us 3x. Negative 3 times x is negative 3x, and then negative 3 times 3 will give us negative 9. Now notice, what do you see there? They're kind of like terms, but they have opposite signs. And therefore, these guys are actually just going to cross each other out. And therefore, your answer is simply going to be x squared minus 9. This x squared minus 9 is called a difference of squares. A difference of squares. Here's why. It's pretty simple. It's a difference because there's a minus, and it's squares because 9 is actually 3 squared, and x, it's obviously x squared. So x squared minus 3 squares. 3 squared. That's why it's a difference of squares. You try one. So let's try this. X plus 5 times x minus 5. So what you should do now is once again pause the video, try it yourself, and then check. Okay, here's what you should have. You should have x times x is x squared. X times negative 5 is negative 5x. 5 times x is 5x. And then 5 times negative 5 is negative 25. It should be fairly clear that these two are opposites, and therefore they're going to cross each other out. And you're left with x squared minus 5 squared. Of course, you're not going to write x squared minus 5 squared. You're going to write x squared minus 25. Awesome. Let's do one last example. And this is as hard as it gets. And I can see the tears coming already as soon as you see what I'm going to write here. But don't cry. We're going to do x plus 1/3 times x minus 1/3. Oh no, fractions! All right, we can do this. Put on your rally caps. We got it. All right, x times x, x squared. X times negative 1/3. Well, that's just negative 1/3 x. Positive 1/3 times x. That's going to be positive 1/3 x. And then 1/3 times negative 1/3. All right, don't be scared. We have a positive times a negative, which is a negative, and a third times a third. Now remember, back from 5th grade, that when you multiply two fractions, all you do is just multiply straight across. 1 times 1 is 1. 3 times 3 is 9. So that is just going to be 1/9. So I get minus 1/9. These guys, of course, are like terms. And therefore, now I'm going to get x squared minus 1/9. Guys, no big deal. I know that you can do this, and you can do this just fine. So work on that assignment. And remember, your goal is to get at least 80%. Do not press submit until you have at least 80% right, because that's how you're going to show me that you understand this, and that's how you're going to get credit in the class. All right. If you have questions, please do email me. I'd be glad to help you. I can even make you another video if you need. All right. So I'll be seeing you tomorrow, or pretty soon, I suppose. Good luck.